Have you ever thought about how it's possible to describe the same thing in different ways? For example, you can describe these bison as being large, furry animals with horns. Or you can say they're dark animals, bigger than cars, with large heads. Or you can describe them as being four-legged mammals with hooves. All these descriptions are correct, even though they're all different. In math, it's also possible to describe number operations in different ways. During the next few minutes, we're going to take a look at some different number operations and how they're described. So pay close attention as we explore some of the properties of numbers. At some point, you may have heard someone ask the question, what are the properties of a specific object or thing? For example, some of the properties of this rock, called pyrite, include the fact that it's hard, it has a gold color, and it has a metallic shininess. A property in science is a characteristic of something. In math, a property is kind of like a rule or the way a mathematical operation is done. In this particular program, we're going to explore some of the properties of addition. The properties we'll explore include the commutative property of addition, the associative property of addition, and the additive property of addition. The people driving these cars are traveling to work in the morning. These people are sometimes referred to as commuters. Commuters move from their homes to a place of work and back again. The word commutative is derived from the word commute, meaning to move around. While the commutative property of addition sounds complicated, it's actually quite simple. Let's use these two different groups of apples to show how this property works. In this group, there are 3 apples, and in this group, there are 5 apples. We can show how these groups are added together using the expression 3 plus 5 equals 8. If we reverse the two groups of apples so that the 5 is first and is added to the group of 3, we still get a sum of 8 apples. The moving around of the 3 and 5 illustrates the commutative property of addition, which states that the order of the numbers being added does not matter. In other words, they can be moved around. We can write the expression like this, where 6 plus 7 plus 3 plus 5 equals 21. Or we can reorder the numbers like this, in which 3 plus 6 plus 5 plus 7 equals 21. The order of the numbers being added doesn't make any difference. So, according to the commutative property of addition, the numbers being added can be reordered, resulting in the same total. Maybe you enjoy eating gummy bears. We'll use the candies to illustrate the associative property of addition. Here are 2 groups of gummy bears. The group on the left has 3, and the group on the right has 5. There are 8 total gummy bears. How can you place them in 2 other groups and still have 8 gummy bears? You can place them in a group of 5 and a group of 3, or in a group of 6 and a group of 2, or in several other ways. No matter how they're grouped, there are always 8 gummy bears. The associative property of addition states that you can add numbers regardless of how they're grouped and still get the same sum. In some mathematical expressions, we use parentheses to group numbers. So, for example, in the expression where 2 plus 7 plus 3 equals 12, we'll place parentheses around 2 and 7. As you know, we need to add the numbers within the parentheses first. Doing this, we add 2 and 7 to get 9, and then add 3 to get a sum of 12. According to the associative property of addition, no matter how we group the numbers or where we place the parentheses, we get the same sum. So, if we place the parentheses around the 7 and 3, we get a total of 10. And when the 2 is added, we get the same answer of 12. If you are like many people, you enjoy eating ice cream. Ice cream is often served by the scoop. This person has 2 scoops of ice cream, and the server asked her if she wants another scoop, but she said no, thank you. You decide. How many scoops does she have? That's right. Of course, she still has just 2 scoops. This is because 0 scoops were added. In math, the additive identity property works in a similar way. The additive identity property states that if you add 0 to a number, then the sum is that number. So, if we have 78 and add 0 to it, we get a sum of 78. As we previously discussed, the commutative property of addition states that changing the order of numbers being added does not change the sum. Shown here are 3 groups of pine cones. The first group has 4 cones, the second group has 6 cones, and the third group has 2 cones. The sum of all the cones is 12. You decide. Rearrange the mathematical expression to illustrate the commutative property of addition. One way to rearrange the expression would be to write it as 2 plus 4 plus 6 equals 12. Or it can be written 6 plus 2 plus 4 equals 12. There are several different ways of writing the expression. Let's now try an example using the associative property of addition. People who work with tools often have a need to organize and display them on pegboards so they can easily locate them. Shown here are 3 groups of tools, which consist of 3 hammers, 6 screwdrivers, and 2 wrenches. We can group the hammers and screwdrivers together with parentheses and add them to the wrenches. We add the 3 hammers and 6 screwdrivers together to get 9 tools, and then add the 2 wrenches to get a sum of 11 tools. Using the associative property, we can group or associate the tools differently and still get the same sum. We could group the 2 wrenches with the 6 screwdrivers by placing parentheses around them. By adding the tools in the parentheses first, we get 8 tools. Then we add 3 hammers to get a total of 11 tools. So, as you can see, using the associative property of addition, even after grouping numbers in different ways, the sum stays the same. During the past few minutes, we explored some of the fascinating features of the properties of numbers. We began by learning that properties of numbers are kind of like rules or ways specific types of mathematical operations are described. We then explored the commutative property of addition, which states that numbers added together can be moved around, resulting in the same sum. In the associative property of addition, we learned that numbers added together can be grouped in different ways without affecting the sum. The third property we investigated was the additive identity property. The additive identity property states that if you add 0 to a number, then the sum is that number. Last, we took a look at some of the ways the various properties of addition can be applied. This rounded out our exploration of the properties of addition. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. This illustrates the property of addition. Number 2. The numbers in parentheses are added. Number 3. This illustrates the property of addition. Number 4. The additive identity property states that if you add to a number, then the sum is that number. And number 5. In the associative property of addition, numbers being added can be in different ways.